1944. 20 million American families were growing their own food. Victory gardens had sprung up in backyards, schoolyards, vacant lots, and rooftops across the nation. By the end of that year, these gardens produced 8 to 10 million tons of vegetables. That was 40% of the entire American vegetable supply, grown by ordinary people, without a single bag of synthetic fertilizer. The secret was not hard work alone. These gardeners knew something. They understood soil secrets that had been passed down for generations, techniques that could triple harvests without spending a dime on chemicals. Then, the war ended, and everything changed. The factories that had been making bombs needed new customers. The same ammonium nitrate that filled explosives could be sold as fertilizer. Within a decade, an industry worth billions of dollars had convinced American farmers to abandon methods that had worked for 10,000 years. The soil secrets did not disappear. They were buried, deliberately, by companies that could not profit from knowledge that was free. Tonight, I am going to dig them up. 10 techniques your great-grandparents used to build soil so rich, it practically grew food by itself. And the disturbing story of why you were never taught any of them. Number 1. Nitrogen-fixing cover crops. The first secret is so powerful that the fertilizer industry spent 70 years trying to make you forget it existed. Certain plants can pull nitrogen directly from the air and deposit it into your soil. They do this through a partnership with bacteria called rhizobium that live in small nodules on their roots. The bacteria convert atmospheric nitrogen into ammonia, a form plants can use. In exchange, the plant feeds the bacteria sugar from photosynthesis. Crimson clover fixes 50 to 125 pounds of nitrogen per acre every year. Hairy vetch fixes 50 to 150 pounds. Red clover can fix up to 250 pounds per acre annually. At current fertilizer prices of 50 to 65 cents per pound, that represents $50 to $160 worth of free nitrogen every single year. From seeds that cost $12 to $38 per acre. During World War II, nitrogen was diverted to make explosives. Farmers had no choice but to use cover crops. The results were remarkable. Soil fertility increased, yields remained stable, and farmers saved money they would have spent on inputs that did not exist. After the war, bomb factories converted to fertilizer production. The industry needed customers. Cover crops became the competition. According to the Journal of Soil and Water Conservation, quote, as World War II ended, the advent of synthetic nitrogen fertilizer softened the use of legume cover crops, end quote. By the late 1950s, cover cropping was largely abandoned. A practice that had sustained agriculture for millennia was erased in less than 15 years. Number 2. The Three Sisters. The second secret comes from Native American farmers who perfected it centuries before Europeans arrived. The Three Sisters is a companion planting system that combines corn, beans, and squash in the same plot. Each plant supports the others in ways that modern agriculture has never replicated. Corn grows tall and provides a natural trellis for the beans to climb. The beans are legumes that fix nitrogen in the soil, feeding the corn that would otherwise deplete it. The squash spreads across the ground with large leaves that shade the soil, conserving moisture and suppressing weeds. The prickly squash vines also discourage animals from entering the garden. But the benefits go deeper than convenience. According to research published in 2025, the Three Sisters system improves soil health, enhances weed control, and increases overall crop yields compared to monoculture planting. The system also produces complete nutrition. Corn provides carbohydrates, beans provide protein, squash provides vitamins and minerals. A single plot feeds a family with balanced nutrition. This knowledge was shared with the Pilgrims at Plymouth in 1621. It saved the colony from starvation. For the next 300 years, American farmers used variations of companion planting to maximize yields and minimize inputs. Then the chemical industry convinced us that plants should grow alone, in neat rows, dependent on purchased fertilizers and pesticides. The Three Sisters was dismissed as primitive, but primitive does not mean ineffective. It means the corporations could not patent it. Number 3. Green manure. The third secret sounds strange to modern ears, but it was standard practice for 6,000 years. Green manure is the practice of growing a crop specifically to plow it back into the soil. You plant it, let it grow, then turn it under before it goes to seed. The decomposing plant material adds organic matter, nitrogen, and nutrients directly where the next crop needs them. The technique dates back to ancient Greece, Rome, and China. The United States Department of Agriculture promoted it in a 1918 publication called Soil Fertility. The recommendation was simple. If animal manure is not available, plow under crops grown for the purpose. Winter rye, buckwheat, clover, and field peas were common green manure crops. Farmers planted them in fall, let them grow through winter, and turned them under in spring before planting vegetables or grain. The benefits were documented for millennia. Green manure adds nitrogen if legumes are used. It increases organic matter in every case. It improves soil structure, controls erosion, and breaks pest cycles by changing what grows in the field each season. Victory gardeners used green manure extensively during World War II. Extension bulletins from the era recommended it as the best way to build soil fertility without purchased inputs. After the war, synthetic fertilizers made green manure seem unnecessary. Why grow a crop you cannot sell when you can buy fertility in a bag? The answer, of course, is that bagged fertility costs money every year, while green manure builds soil that improves forever. But that answer does not generate profits for chemical companies. Number 4. The 4-year rotation. The fourth secret revolutionized European agriculture in the 1700s. Then American farmers forgot it in the 1950s. The 4-year crop rotation divides land into 4 sections and cycles different crop families through each section every year. A typical rotation might be legumes in year 1, root vegetables in year 2, fruiting crops in year 3, and leafy greens in year 4. The system works because different plants have different needs and different effects on soil. Legumes add nitrogen, root vegetables break up compacted soil, fruiting crops use heavy nutrients. Leafy greens benefit from the residual fertility. Pests and diseases also struggle with rotation. Insects that feed on tomatoes cannot survive a year of beans, followed by carrots, followed by lettuce. Soil-borne diseases that attack one plant family die out when their host is absent for 3 years. Research published in 2025 confirmed that crop rotation increases yield and revenue while reducing input costs and restoring soil fertility. One study found that 4-year rotation increased yields by 48% compared to continuous monoculture. The rotation system was so successful that it ended the practice of leaving fields fallow. Before rotation, farmers had to rest their land every few years because continuous cropping depleted the soil. With rotation, every field could produce every year. Modern industrial agriculture abandoned rotation in favor of monoculture because monoculture is easier to mechanize. The same crop in the same field year after year allows standardized equipment and simplified management. But it also requires ever-increasing chemical inputs to compensate for the fertility and pest control that rotation provided naturally. Number 5. Wood ash. The fifth secret was literally going up the chimney in every American home during World War II. Wood ash is a powerful soil amendment that provides potassium, raises pH, and adds trace minerals. Its composition is approximately 0.13 on the NPK scale, meaning it contains no nitrogen, about 1% phosphorus, and 3% potassium. It also contains significant calcium, similar to agricultural lime. Potassium is essential for flowering and fruiting. Plants deficient in potassium produce fewer flowers, smaller fruits, and weaker stems. Wood ash delivers potassium in a form plants can use immediately. The pH-raising effect is equally valuable. Most vegetables prefer slightly acidic to neutral soil, with a pH between 6 and 7. Soils that have become too acidic from years of rainfall or chemical fertilizer use can be corrected with wood ash applications. Victory gardeners saved their fireplace and wood stove ash all winter, then spread it on garden beds in spring. The practice cost nothing. The materials were already being produced for heating and cooking. According to the University of Georgia Extension, wood ash is a natural substitute for agricultural lime and can significantly improve crop growth in potassium-deficient soils. The practice declined as central heating replaced wood stoves and as bagged fertilizers became cheap and available. Why save and spread ash when you can buy potassium in a bag? The answer is that wood ash is free, renewable, and builds soil structure in ways synthetic potassium chloride does not, but free does not generate sales. Number 6. Fish fertilizer. The sixth secret comes from coastal communities that turned waste into agricultural gold. Fish fertilizer has been used for centuries by farmers near oceans, rivers, and lakes. The most famous example is Squanto teaching the Pilgrims to bury fish with their corn in 1621. The decomposing fish provided nitrogen, phosphorus, and trace minerals that transformed poor coastal soil into productive farmland. Fish emulsion, the liquid form, has a typical NPK ratio of 5:1:1 or 4:1:1. That high nitrogen content makes it excellent for leafy growth and early season feeding. But fish fertilizer provides more than NPK. It contains calcium, magnesium, and trace minerals that synthetic fertilizers lack. It also feeds beneficial soil microorganisms that improve soil structure over time. During World War II, coastal victory gardeners used fish scraps and seaweed extensively. By the Civil War, farmers in Westport, Connecticut had become the leading onion supplier to the Union Army using fish and seaweed fertilizer. The practice works because fish contain complete proteins that break down into plant-available nitrogen. Unlike synthetic nitrogen that can burn roots and leach away quickly, fish nitrogen releases slowly as soil microbes decompose the organic material. Fish fertilizer fell out of favor when synthetic nitrogen became cheap. The smell discouraged suburban gardeners who did not understand the benefits. But organic farmers never abandoned it. Today, fish emulsion remains one of the most effective organic nitrogen sources available. Number 7. Compost tea. The seventh secret takes ordinary compost and multiplies its power through water extraction. Compost tea is a liquid made by steeping finished compost in water, often with aeration to encourage beneficial microorganism growth. The resulting liquid contains dissolved nutrients, beneficial bacteria, fungi, and organic compounds that can be applied directly to soil or sprayed on plant leaves. The benefits go beyond simple fertilization. Compost tea introduces beneficial microorganisms that compete with plant pathogens. It contains humic acids that improve nutrient uptake. It provides small organic molecules that plants can absorb through their leaves. Research published in 2025 found that compost tea is rich in nutrients required by plants, small organic acids, humic acids, and beneficial microorganisms and their metabolites. Studies have documented improved plant growth, increased disease resistance, and enhanced soil biology from regular compost tea applications. The technique requires no purchased inputs beyond the initial compost. A 5-gallon bucket, some finished compost, water, and optional aeration can produce gallons of liquid fertilizer. That liquid can then be diluted and applied to hundreds of square feet of garden space. Victory gardeners made compost tea by the barrel. Extension publications from the era described methods for extracting maximum nutrition from limited compost supplies. The practice allowed gardeners to spread fertility across larger areas than solid compost could cover. Industrial agriculture has no place for compost tea because it cannot be standardized, packaged, or sold at scale. The beneficial organisms vary with every batch. The nutrient content depends on the original compost. These variations make compost tea perfect for home gardens and small farms, but useless for corporations seeking consistent products to sell. Number 8. Bone meal. The eighth secret transformed slaughterhouse waste into phosphorus gold. Bone meal is exactly what it sounds like. Animal bones ground into powder. Its NPK ratio is approximately 4:12:0, meaning it provides moderate nitrogen and high phosphorus with minimal potassium. It also contains substantial calcium, around 20% by weight. Phosphorus is essential for root development, flowering, and fruit production. Plants deficient in phosphorus develop weak root systems, delayed maturity, and reduced yields. Bone meal delivers phosphorus in a slow-release form that feeds plants for months. The calcium content provides additional benefits. Tomatoes and peppers suffer from blossom end rot when calcium is insufficient. Bone meal applied at planting time prevents this common problem. Traditional application involves mixing bone meal into the planting hole before setting transplants or bulbs. Approximately 10 pounds per 100 square feet enriches an entire bed. A tablespoon per planting hole feeds individual plants. During World War II, bone meal was widely available because it came from the same livestock providing meat for the war effort. Nothing was wasted. Bones that would otherwise be discarded became valuable agricultural inputs. The practice declined as concentrated synthetic phosphorus became available. Triple superphosphate delivers more phosphorus per pound than bone meal. But synthetic phosphorus is also more prone to runoff, more damaging to waterways, and more depleting to finite phosphate rock reserves. Bone meal recycles phosphorus that already exists in the food system. Number 9. Sheet mulching. The ninth secret builds soil by copying how nature does it. Sheet mulching, also called lasagna gardening, creates new garden beds by layering organic materials directly on existing ground. No tilling, no digging, no disturbing the soil life that exists below the surface. The basic method starts with a layer of cardboard or newspaper to smother existing vegetation. On top of that, alternating layers of nitrogen-rich green materials and carbon-rich brown materials are stacked like lasagna. Kitchen scraps, grass clippings, and fresh manure provide nitrogen. Dried leaves, straw, and wood chips provide carbon. A final layer of compost or soil allows immediate planting. The system works because it mimics the forest floor. In nature, leaves fall, organic matter accumulates, and decomposition happens in place. Earthworms and soil organisms pull material downward. Nutrients cycle without mechanical intervention. According to Oregon State University Extension, sheet mulching is a no-till, no-dig method that helps maintain carbon sequestration, conserves water, and prevents soil erosion. The technique requires patience. Fresh sheet mulch beds benefit from several months of decomposition before planting, but existing beds can be sheet mulched in fall and planted in spring. Over time, the practice builds soil depth and fertility that would take decades to achieve through conventional methods. Sheet mulching was common in victory gardens because materials were free and labor was available. Newspapers, leaves, kitchen scraps, and manure could be layered without purchasing anything. The resulting beds produced abundantly for years. Number 10. Biochar. The 10th secret is the oldest and most powerful of all. It comes from the Amazon rainforest, where indigenous farmers created soil so fertile it remains productive after 2,000 years. Biochar is charcoal produced by burning organic material in a low-oxygen environment. When incorporated into soil, it provides a stable structure that persists for centuries. That structure holds nutrients, retains water, and houses beneficial microorganisms in ways that ordinary organic matter cannot match. The most famous biochar soils are the terra preta, or black earth of the Amazon basin. Created by indigenous people starting around 450 BCE, these soils cover thousands of acres in a region otherwise dominated by poor, acidite tropical soils. They remain so fertile that they are still being mined and sold as potting soil today. The yield improvements are remarkable. According to research from Cornell University, charcoal amendments significantly decrease nutrient leaching and increase crop growth. University trials have documented yield increases of up to 800% compared to unamended tropical soils. Even in temperate regions, terra preta-type soils produce double the yields of surrounding areas. Biochar also sequesters carbon permanently. Unlike compost or organic matter that decomposes within years, biochar remains stable for thousands of years. Every pound of biochar in soil is a pound of carbon removed from the atmosphere indefinitely. Victory gardeners used charcoal from their fires as a soil amendment without understanding the full science. The practice was considered folk wisdom. Modern research has validated that folk wisdom with peer-reviewed studies from major universities. The fertilizer industry cannot sell biochar effectively because biochar is produced locally from waste materials. A farmer with wood scraps and a simple kiln can make biochar indefinitely. There is no supply chain to control, no patent to protect, and no recurring purchase to guarantee. 10 secrets. 10,000 years of accumulated wisdom. All of it systematically buried by an industry that could not profit from knowledge that was free. Nitrogen-fixing cover crops. Three Sisters companion planting. Green manure. 4-year rotation. Wood ash. Fish fertilizer. Compost tea. Bone meal. Sheet mulching. Biochar. These techniques tripled harvests for our great-grandparents. They sustained civilizations from ancient Rome to pre-Columbian America to World War II victory gardens. They built soil that improved with every passing year, instead of degrading with every application of synthetic chemicals. Then the bomb factories needed new customers. By 1946, the United States government was marketing surplus ammonium nitrate to farmers. By 1950, extension services were promoting synthetic fertilizers as modern and scientific. By 1960, cover crops were largely abandoned. By 1970, traditional soil building practices survived only among a shrinking population of organic farmers and old-timers who remembered better ways. The fertilizer industry spent billions of dollars convincing us that soil is just a medium to hold roots while we pour purchased nutrients around them. They taught us that fertility comes from factories, not from biology. They made us dependent on products we have to buy every single year. But the soil remembers. The science still works. The secrets are still there for anyone willing to learn them. 20 million Victory Gardens fed 40% of America in 1944. Without synthetic fertilizer, without pesticides, without any of the inputs modern agriculture claims are essential. The question is not whether these methods work. History already answered that question. The question is whether you are ready to stop paying for something your great-grandparents got for free.